So here we are at our final topic, and this is kind of taking everything we've learned and putting it together into a real world situation. What we're going to be doing today is we're going to be writing the actual function given a situation. Why is this important? Well, the reason we have functions and we have these equations is so that we can determine a possible outcome down the road and make a prediction. So if we look at this word problem, the enrollment of a school in 2000 was 1,200. Since then, it has increased at a rate of 35 students per year. Write an equation to represent the enrollment of the school each year after 2000. And then look what it says, identify your variables. So let's go back through and do some highlighting. We're talking about the enrollment, and that enrollment was 1,200, okay? Since then, it's increased. So we're having an increase, 35 per year. What are we doing here? We're going to be writing an equation. Now, here's what this equation is. This equation represents the enrollment. Listen to what I just said. This equation represents the enrollment, so it's going to equal the enrollment after 2000. So looking at this situation, think about what our variables might be, okay? What would the independent variable be? What is causing the change? More years. There's more students, the more years. If we stop at a year, it doesn't change. So it's the number of years. What's dependent? Well, what is our outcome? What are we looking at? Well, we're writing an equation for the enrollment. That is our dependent variable. So now we got to go back up and look. What was the rate at which the enrollment was changing? 35 per year. That's your rate of change, okay? What was its initial value? What did the school start at? 1,200. So each one of these things is a component of our equation. The number of years being independent, that's your X. Your enrollment is your Y. So those would be your ordered pairs when we solve this equation. But remember, we're creating an equation, okay, that represents the enrollment each year. So meaning this is going to be an equation that could be used for each year. What was that rate of change? Well, that rate of change is my slope. Please write that down. And the initial value is my y-intercept. So we are going to be looking for all of these labels on your notes. So now that we know each thing, we can write our equation. My enrollment was y. My rate of change, which is my slope, was 35. The number of years is x. And then my initial value, where I begin, is 1,200. So let's look at another one. The registration at a preschool is $125. Then parents must also pay $475 per month. Write an equation to represent the total cost after each month. Identify your variables. So let's look at this. We're looking at the registration. The registration is what we're dealing with here, right? Now, $125, that is a registration fee. Okay. Parents must also pay $475 per month. We're writing an equation to represent the total cost after each month. So let's go identify our variables. I think that's what we need to do first. So my independent variable, what is going to change? I'm writing an equation for my total cost. Well, what does my total cost depend on? My total cost is going to depend on the number of months. If a student isn't enrolled each month, the price is going to change. Therefore, my dependent is total cost. Well, what is the rate at which it's changing? $475 per month. Okay, so what is its initial value? Remember, an initial value is a beginning point. It's a starting amount. It's a one-time fee. when we're dealing with certain real world situations. So what is a one-time fee in this situation? Exactly, $125. You're not going to pay that registration fee every month. You only pay it once, okay? So remember, the months was my X, the total cost is my Y, my rate of change is the slope in my equation, and my initial value is my y-intercept. Again, we're looking that you have these labeled, that it says slope, y-intercept, X, and Y. This is telling you what each thing is in your equation. So then you can go write it. Y equals 475x plus 125. You should be seeing a pattern here at this point. So here's a third one, but you're going to pause and try this on your own. Okay, let's see how you did. So there's 18 gallons of gas in the car when you start your trip. There's some key words there. Okay. Then each hour, and I'm highlighting constantly the words each hour, okay, 2.5 gallons are used. So we're writing an equation to represent the gas left after each hour. The each is very, 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 very big. That's why it's highlighted in multiple places, because it's being repeated. So if we identify my dependent variable and independent, okay, the independent is the number of hours, because that's what's changing. And then that's going to state how much gas is left in the tank. The longer you travel, the less gas there will be. So what's the rate of change? Well, the rate that it's changing is 2.5 per hour. But notice something, okay? I'm not gaining that gas per hour. My gas is going to be going down per hour. So it's important that you emphasize that the rate at which it's changing is negative 2.5. It's going down 2.5 every hour. Well, what did it start with? It started with 18 gallons. So when we put this together, we go back and say, okay, my independent is my X. My dependent is my Y. My rate of change is my slope. And my initial value is my y-intercept. So you write your equation. Y equals, now you can write it negative 2x and 2.5x plus 18, but you would probably see it written this way in a multiple choice question because you're starting with your 18 gallons and every hour you subtract more gas. So this is that situation now that I'm showing you. Sometimes your slope does come second. But had you written it the other way, that would still be okay too. Okay? Another one for you to try on your own. Pause the video now. Look at your other 3 examples. Okay? We're going to be checking that to see who understood it and got it right. So we want you to apply this strategy every time you're faced with a real world word problem. Break things down into manageable parts.